This question says give the local and absolute extreme values of f. Okay. Um, because that is going to negative infinity, that is going to positive infinity. There are no absolute extreme values. Nothing ever, this is going to negative infinity, that's going to positive infinity. There's nothing that's going to get smaller than negative infinity. There's nothing going to be bigger than positive infinity. So there's no absolute. However, that is a local maximum. That is a local maximum. This one's a local minimum, and that one's a local minimum. I'll describe the end behavior function. Okay, basically we're only looking at that. Okay, and I don't really care that's a radical 2. I care that it's a positive number. Okay, it's a positive a value. It's a cubic. So every positive a value cubic function is going to have an end behavior that does something like that. Okay, so option D is our correct answer. Again, this is the same type of question. It's a 7th degree polynomial, so it's odd. So it's just like a 3rd degree polynomial. And when a is positive, it's going to be like a positive 3rd degree polynomial. Okay? So your end behavior is going to, in the first quadrant, end like that. Third quadrant, end like that. Okay? So option B matches that. Here we've got a 4th degree polynomial. Okay? And a, again, is positive. Okay, so if a is positive, 4th degree polynomial, as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. So that's the end behavior of any 4th degree polynomial when a is positive. So option D in this case. Okay, 6th degree polynomial, very similar to a 4th degree. Anything that's even is going to show this even degree is going to show the same behavior. However, now a is negative. Okay, so if in the first one or the prior question we had a 4th degree and it was positive, so it did that. We know that a negative out front of the function was a reflection across the x-axis. So it's going to take and make my end behavior like those red arrows. Okay, in my 6th degree polynomial, then because it's 6th degree, it's going to have a possibility of 6 zeros and a possibility of no more than 5 turning points. However, end behavior, all they're asking for is option A. Okay, here it says use end behavior and analysis of dominating terms to determine which function matches the graph. End behavior, as x is going to negative infinity, y is going to positive infinity. As x is going to positive infinity, y is going to positive infinity. Okay, so it's even. Okay, the degree is even, so it's either, I know it's not x squared because of the nature of what's going on right there. It is, x to the 4th, x to the 6th, x to the 8th, so on. Okay, and now it's got to be a positive a coefficient, so whatever my a out front is, it's positive. Now look over here at my options. Okay, I don't have anything bigger than x to the 4th. I know it's not x to the 3rd, so it's not b, it's not d. It must be a or c, and c is the only one that's positive. Here it says the comprehensive graph of the polynomial function y equals f of x is shown. How many real zeros does the function have? It only crosses the x-axis one time, so that's one real zero. So the comprehensive graphs of 4 polynomial functions are shown in A through D. Which of the graphs cannot be that of a cubic polynomial function? Okay, this could be a cubic, one x-intercept, and at most, here we really don't have any maximum or minimum turning points basically. That might be like an inflection point where my arrow is. All right. B, you've got 1, 2, 3 x-intercepts, so that's okay. And you got 1, 2 turning points, so that's okay. So that could be a cubic. Here, you've got 2 zeros right there, okay, because that's a double root, all right, because you're bouncing off the x-axis. You got another one, so there's 3 and there's 4. So there's 4 zeros, and a cubic, because it has a leading degree of 3, can only have 3 zeros. So this has 4 zeros, so that's not going to work. And also this has 1, 2, 3 turning points, and at most a cubic can have 2 turning points because of the n minus 1 rule. Okay, so that cannot be a cubic. Over here, for the same reason, you got 1, 2. If I zoom in, okay, so I got 1, 0. Looks like you might have 2 zeros here. Okay, whether you're tangent or not, it's kind of a question, but if you're not tangent, you intersect there and then again there. Okay, so there's 1, 2, 3, 4, 5 zeros here. Okay, so that's not a cubic. Again, it's also got 1, 2, 3, 4 turning points. So this could be a 5th degree polynomial, not a 3rd degree. So C and D, not cubics. Use the intermediate value theorem to show that the function has a real zero between the two numbers given. Then use your calculator to approximate the zero. Okay. Here's your polynomial. Here's 1. Here's 2 for my x values. They're basically saying, okay, if this is your function, when you plug in x value in of 1, the y value you get back in this case is -3. Just try that, plug that in, you get -3 back. Here it's saying plug in 2 into this function, you get the y value of 7 back. So whatever your function looks like, and I don't really care, you know, it's a quadratic, so it's going to look like it's going to be a parabola, but I don't really care necessarily what the function looks like to kind of explain this concept. They're saying you have some function, and when you plug x in, you get a y value up here, or I'm sorry, you get a plug value of 1 in, you get a y value down here of -3. So there's a point right there. And then you go to an x value of 2, and you plug that into your function, and now you're going to get a y value up here of 7. Okay? Well, as my graph progresses from left to right, get from this point here to that point there, and this span from 1 to 2 on the x-axis, it has to cross the x-axis somewhere. So there is a 0 there. Okay, the intermediate value theorem says if the signs change between two x values, the y value signs change, then that means you must somewhere cross 0, because that's the value of where positive and negative numbers change. Okay, and then it says use your calculator to approximate the 0. There you would go into, you would type this into y1 and go into second calc. Go over to your 0 option, I think it's option 2, and then choose a left bound, which would be a number to the left of where you think your 0 is, and then choose a right bound, which is a number to the right of where you think your 0 is. Hit enter on both those. It's going to ask you to guess. Hit enter again, and then it's going to find that 1.4, and you'll just need to round that to the nearest one. Okay, this question here, use the intermediate value theorem to determine if there is a 0 between the two numbers. So will the intermediate value theorem guarantee a 0 between 1 and 1.5? Okay. So we do this. Evidently, when I plug 1 in, let's kind of think about what I would get here. I don't have my calculator, so we're going to do some extended math here. Fractions, maybe. For 1.5 at least. We got 2. If I use the value of 1, we get 2 times 1 cubed minus 8 times 1 squared plus 1 plus 16. So that's going to give me 2 minus 8 plus 1 plus 16. So that is going to give me a positive 2 minus 8 is negative 6 plus 16 is 10 plus 1 is 11. Okay? So P of 1 is equal to 11. Okay? Now P of 1.5, plugging in 1.5, and here I'm going to go 2. 1.5 is 3 halves, cube that, minus 8 times 3 halves squared plus 1 plus 16. That's going to give me, 27. 8 times 2 is 54 eighths. That's going to be 9/4. 8 was that minus 72 fourths. Okay, when it's going to be 144 eighths. plus then 8 plus then 16 times 8, 128. Okay, so we got 54 minus 144 plus 8 plus 128 gives me 46 over 8. Okay, which 46 over 8 then is 5.75. Okay, so P of 1.5 is 5.75. Now, because they're both positive, there's no sign change, so it does not guarantee that I cross the x-axis. Okay, so I've got some possibilities here. Basically at 1 and 1.5, if that's an x value of 1, that's an x value of 1.5. They're telling me here I've got a y value of 11, and then here I've got a y value of 5.75. Okay, now my graph could do something like that, and it obviously doesn't cross the x-axis, so we would not have a 0. But just because I have those 2 points there does not mean that my value doesn't, or my graph doesn't do something. Computer froze. There you go. It doesn't do something like that. Okay. I could have P of 1 being 11, P of 1.5 being 5.75, but still cross the x-axis between those two. Okay. So just because I don't see a sign change doesn't mean the intermediate value theorem doesn't provide me a 0. Okay. The only thing that the intermediate value theorem says is that if the signs are different, then you cross the x-axis. But if the signs are the same, you don't know whether you cross the x-axis or you don't cross the x-axis. Okay? So it does not guarantee a 0 here because the signs are both positive. My option would be no. Okay, this is saying use synthetic division to divide the polynomial. Remember, when you do synthetic division, it doesn't look like we're going to have to do that on this one, but if you have missing terms, you need placeholders. So we got third, a second degree, a first degree, and then our constant. And then we'll go, remember, minus 2 is going to, the 0 would go here. If x plus 2 is a factor, minus 2 is a 0. Bring my 2 down, multiply gives me negative 4. Bring my 6 down, multiply gives me negative 12. Bring my negative 3 down, gives me a positive 6. There's my 0. Okay. Now, if it was x to the third, this is x squared, and this is x. And there's my polynomial. Option B. Okay, so let's consider the graph of the polynomial function to the right, defined by p of x. The x-intercepts are negative 2, 1, and 3. What are the linear factors? Okay, not a whole lot of math here. We talked about if these are the zeros working our way backwards, the factors are x minus those. So x minus the negative 2 is this x plus 2. X minus 1 is this x minus 1. And x minus 3 is that x minus 3. If I were to end up distributing those things, basically foiling 2 times, I'll multiply out and get x cubed minus 2x squared minus 5x plus 6. Okay, this question, if negative 1 is a 0, then x plus 1 is a factor. If 4 minus 5i is a 0, x minus that is a factor. If that is a 0, then its conjugate is a 0. Okay? I'm going to distribute my negative through in both those. Minus 4 plus 5i. Minus 4 minus 5i. Okay? Now I'm going to take these last two groupings and I'm going to multiply them out. So x squared minus 4x minus 5xi minus 4x plus 16 plus 20i plus 5xi minus 20i minus 25i squared. Cancel, 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 cancel. So give me x plus 1, x squared minus 8x plus 41. Distribute this now. It'll be x cubed minus 8x squared plus 41x. And then plus x squared minus 8x plus 41. Combine like terms, x cubed minus 7x squared plus 33x plus 41. So that 33 is what they were looking for here. Okay, this is pretty much the same type of question. We got my zeros here, so the factors that create them. We're going to have x minus negative 3, so x plus 3, x plus 1, and x minus 4. Okay, that's p of x. But there's an infinite number of cubic functions that go through those 3 points. So I need the specific one, so I'm going to put an a out here, and that's where this number here is going to come to play. We'll multiply all this out, and we get a going to be, multiplying these first two, be x squared plus 3x plus 1x is 4x plus then 3, and I got my x minus 4 here. So now I'll have a, multiply this out, x times x squared is x cubed plus 4x squared plus 3x minus 4x squared minus 16x minus 12. So we got a, x cubed, 4x squared, negative 4x squared, they go away, minus 13x minus 12 then. That's my p of x is equal to that. Okay, now p of x, they're telling me right here, if x is negative 2, p of x is 18. So 18 is equal to a. Now this will be negative 2. X is negative 2. So I'll go negative 2 cubed minus 13 times negative 2 minus 12. Okay. So now I'm going to a. That's going to be, what, negative 8 plus 26 minus 12. So negative 20 plus 26 is 6, so 6a is equal to 18, so a must be 3. So if a is 3, I'll come back up to this point here. I'll plug 3 in for a. So now when I multiply that 3 through, it's 3x cubed minus 39x minus 36. And there's my polynomial. Okay, so for that following polynomial, 5 is a 0, find the remaining zeros. Okay, so here we're going to do some synthetic division. One, negative 13, 60, and negative 100. I know 5 is a 0, so I'll put 5 there. Bring my 1 down, give me 5. What's this going to be? Negative 8 gives me negative 40, so there's 20, there's 100, so there's 0. So this was x cubed, this is going to be x squared, so I have that x squared minus 8x plus 20. Okay, that is my depreciated function. If I combine that with x minus 5, which is going to be the factor that this came from, if I multiply that x minus 5, x squared minus 8x plus 20 out, I'm going to get the original polynomial we started with. Okay. However, this x minus 5 is a linear function, or a linear factor, and the x squared minus 8x plus 20 is a quadratic factor. We don't want quadratic factors. Because we want this to be linear factors, so we're going to need to break this down further. Okay, well, it's squared, so we can use a quadratic formula here. If I go opposite of b, so 8 plus or minus b squared, which will be 64, minus 4 times a times c all over 2a. Okay, that's gonna give me my x values, give me my other zeros. 64 minus 80 is going to be, what's that, 16? Negative 16. 8 plus or minus negative 16 as my discriminant. So square root of negative 16 actually ends up being 4i all over 2. Okay, so cancel, cancel, cancel gives me 4 plus or minus 2i. And that's what you're seeing here. 4 plus 2i, 4 minus 2i. Those are my other two zeros. Okay, here it says find list all possible zeros. Okay, so you can go factors of p over q. Okay, so here's my factors here of p are plus or minus 1, 2, 4, 7, 14, and 28. And then q factors are plus or minus 1. So all of these are p, these are q. All possibles are p over q. So these over 1 will just give me that list right there. Okay. So I use a graph to eliminate some of the possible zeros. Okay. So basically that's saying type this function into y1 and see which ones of these do not work. Okay. When I type it into y1, I get this graph here. Okay. And obviously then positive 14, which would be over here somewhere, and negative 14, which is over here somewhere, is not going to work. Same thing, positive 28 is over here somewhere, negative 28 is over there somewhere. Those are not going to work. Okay, so nope and nope. So now it's depreciated my list down to these 1, 2, 4, and 7. Okay, and if I go ahead and type this into my calculator and I start looking for zeros, I'm going to find them to be 2, negative 2, and 7. And then ask us to factor the polynomial. Alright, well, if those are my rational zeros, okay, and I know it's a cubic, I got 3 zeros, it's going to be x minus 2, x minus a negative 2, so it becomes x plus 2, and x minus 7. So the polynomial function I of t is equal to that, represents the yearly income or loss from a real estate investment for t in time of years. After what year does the income begin to decline? And so here we're looking for, so the polynomial function I of t is equal to negative 0.1t squared plus 1.8t represents the yearly income or loss from a real estate investment where t is in time in years. After what year does the income begin to decline? This is a quadratic function. It's negative, or its a value is negative, so that tells us it's concave down. Okay, so if we visualize a parabola that's concave down, we have a maximum value. We'll have a maximum point. Okay, so it looks something like that. Okay, well, that point right there, the vertex, is the breaking point. From the left of that, you are increasing. To the right of it, you are decreasing or declining. Okay, so we're going to look for the value of t in which this thing starts decreasing. Okay, so we're going to go the opposite, t. That t value for the vertex is the opposite of b over 2a. So the opposite of b is negative 1.8 over 2a is going to be negative 0.2. We'll divide that, and I'm going to get 9. So t is 9. So after 9 years, we start to decline. Find a function p of x defined by a polynomial of degree 3 with real coefficients satisfies a given condition. We have a 0 of -5 and a multiplicity of 2. So what that means is p of x is going to look like x plus 5, 20 squared. As a 0 of 10, having a multiplicity of 1. So it's going to be x minus 10. Okay, so that's going to be a cubic function. Degree of 3, that makes sense. It also tells me p of 0 is -250, so that's going to help us find the particular one. So we need an a value out here. Multiplying this out, I can multiply this out first, or I can find that a value first. It doesn't really matter. It might be easier to find the a value first, because when I know x is 0, okay, I'll have a 5 squared -10 equal to 250, -250. Okay, that's when x is 0. So that's going to be -250. 25 times 10 is -250. So a is going to be 1. So that's nice. Okay. Now I need to, this value here is now 1. I need to go through looking at this function and multiply that out. Okay. Well, x plus 5 squared is going to be, color, will be x squared plus 10x plus 0.5. And now I'll multiply that by x minus 10. A value is 1, so that 1, you really don't notice it. Okay. X times x squared is going to be x cubed. I'll have plus 10x squared plus 25x. Then I'll have minus 10x squared minus 100x minus then 250. So now combine like terms, it's going to be x cubed. Positive 10x squared, negative 10x squared, those go away. 25x negative 100x gives me negative 75x minus then 250. And that then happens to be option C.